Alright, so we are going to do some practice. So exercise 4D. So let's look at question 1. And here we use the substitution z equals y over x. Okay, so let's try. So because the equation is dy by dx, so we have to replace dy by dx in terms of z and x. Okay, so we should write the subject to be y. So z equals y over x. So y equals z times x. So dy by dx equals dzx by dx, which is z plus x times dz by dx. Okay, dz by dx. So now we can replace dy by dx. So it is z plus x times dz by dx equals, so y over x. Okay, y over x is z, and then x over y is 1 over z. Okay, and then we can cancel the line terms. Okay, so finally it is x times dz by dx equals 1 over z. Okay, so as we know, we can here obviously we can use separating variables method. So it is z times dz equals 1 over x times dx, and then we integrate it. So finally it is 1 over z, 1 over 2 z squared equals ln absolute value of x plus constant c. Okay, and it is because x is greater than 0. How? Okay, because x is greater than 0. X is greater than 0. So we can remove, okay, we can remove the absolute value sign. Okay, so x is greater than 0. So we can remove the absolute value sign. So it becomes 1 over 2 z squared. 1 over 2 z squared equals ln x plus constant c. All right, and finally, okay, finally we can replace z in terms of x and y. So it is 1 over 2 y over x bracket square equals ln x plus constant c, and we multiply 2 first. It is y square over x square, and then 2 ln x plus 2c, and finally we can write it as y square equals 2x squared ln x plus 2c x squared. Okay, so this is the answer of question 1. And let's look at question 4. Question 4 the same. So also we use the same substitution, z equals y over x. Okay, so let's see. So actually dy by dx we know in dy by dx. Okay, dy by dx in A we have found, which is z equals x times dz by dx, and then we can get, okay, we can get z plus x times dz by dx equals, so x cubed and then plus 4y can be written as zx to the power of 3. Okay, so 3 times x here was the same, zx to the power of 2. Okay, and simplify it, z plus x times dz by dx equals, and here it is x cubed. Okay, x cubed plus 4z cubed x cubed over 3x cubed z squared, and then we cancel the common factor x cubed. Okay, finally it is z plus x times dz by dx equals 1 plus 4z cubed over 3z square, okay, 3z square. And then we can continue to simplify. We group the term with z together, okay, so it will be minus, here it will be 3z to the power of 3, okay, because minus that, okay. So finally it is 1 plus z to the power of 3 over 3z square. Alright, so we can get this. And finally, we can separate the variables, okay? So it will be 3z squared over 1 plus z to the power of 3 equals 1 over x dx, okay? And now we can do integration, okay? Sorry, here it is dz. Alright, so look at the left hand side. Left hand side, actually we can move 3z squared into d, so it becomes, okay, so it becomes 1 over z plus 1 plus z to the power of 3, and then here it becomes z to the power of 3, okay, equals the right hand side, okay, and here we can also add 1 to z cubed, okay, it is the same also. And finally, it becomes ln absolute value of 1 plus z to the power of 3 equals ln absolute value of x plus constant c, okay? So this is this one, okay? And pay attention, in this question, actually it gives us x greater than 0, but however, I think it should give us y equals 0, okay, so that we can get z is greater than 0, so we can remove the absolute value sign. So we can remove the absolute value sign, okay. So after that it becomes ln 1 plus z to the power of 3 over x equals constant c, and using the definition of ln, it becomes 1 plus z to the power of 3 over x equals e to the power of c, okay? So you can let a be e to the power of c, so a greater than 0, okay, a greater than 0, so it becomes 1 plus z is replaced by y over x and then to the power of 3, and then equals a times x, okay? So it becomes 1 plus y to the power of 3, x to the power of 3 equals a times x. So finally, it becomes x to the power of 3 plus y to the power of 3 equals a to the power of x to the power of 4. And finally, y cubed just equals x cubed times ax minus 1, okay? So this is the answer of question 4. So actually we should add condition that y greater than 0, okay, so that we can remove the absolute value sign, okay. So this is question 4, and let's look at question 6, okay. Question 6. So use the substitution z equals x to the power of 1 over 2 to transform the differential equation, okay, differential equation. So because z equals x to the power of 1 over 2, so z squared equals x, okay? So dx by dt equals dz squared by dt, and this is a composite function, it becomes 2z times dz by dt, okay? So now we can do replacement, so we can get 2z times dz by dt plus t square, x is z square equals t square, x to the power of 1 over 2 is z, okay? So we can, so let's see whether we can simplify the equation, okay? So 2z times dz by dt equals, if we move this term to the right hand side, it becomes t square z minus t square z square equals t square z minus z square, okay? So 2z times dz by dt. And now obviously we can separate the variables, okay? We can separate the variables, okay? So actually, if you cannot simplify the equation like this pattern, I think you may try the previous three types we have learned to solve the differential equation, okay? So separating variables method, this is the first thinking, and the second one is one side can be written as the derivative of a product, and the last type is we should consider the integrating factor, okay? So here we can use separating variables method, and it becomes 2z over z minus z square, 2z minus z, and then times dz equals, okay, equals t square, okay, times dt, okay? So here, this one, we can cancel common factor also. It becomes 2 over 1 minus z dz equals t square dt, okay? dt, and then we do integration on both sides. So integrate 2 over 1 minus z dz equals the integral of t square, okay? So left hand side, just the left hand side, actually you can the left hand side just ln 2 ln absolute value of 1 minus z, but we have to use a negative number to adjust it, okay? To adjust a negative one to adjust it, okay? To adjust it. So it is ln 1 minus z, and then equals 1 over 3 times t to the power of 3 plus constant c, okay? Plus constant c, okay? So here it becomes, okay? So it, and then it is ln, actually we can exchange the two terms, okay? So, or maybe it is 1 minus z, and then equals negative 1 over 6, negative 1 over 6, and then t to the power of 3, and then minus 1 over 2, okay? Minus 1 over 2c, okay? Minus 1 over 2c, okay? So now we use, okay? Now we use the definition of ln. So it is absolute value of 1 minus z equals e to the power of negative 1 over 6 t cubed, and then minus 1 over 2c, okay? Minus 1 over 2c, and which is e to the power of negative 1 over 6 t to the power of 3, okay? To the power of 3, and then times e to the power of negative 1 over 2c. And this one can be regarded as a, okay? This one can be regarded as a, okay? Regarded as a. So we can get that, okay? So let a be e to the power of negative 1 over 2c. So a is greater than 0. So we can get the absolute value of 1 minus z equals a times e to the power of negative 1 over 6 t to the power of 3, okay? t to the power of 3. Okay, so finally it is 1 minus z equals positive negative a e to the power of negative 1 over 6 t to the power of 3. Okay, but however, okay, so we can replace the constant positive or negative a be a constant k, so it means that k can be all real number. Okay, so we can let, okay, a to be a constant, a positive negative k to be constant k, so it becomes 1 minus z equals k times e to the power of negative 1 over 6 t to the power of 3. Okay, t to the power of 3. And finally we can replace z in terms of, okay, replace z in terms of x, so it will be x to the power of 1 over 2 equals k times e to the power of negative 1 over 6 t to the power of 3. Okay, t to the power of 3. And finally, okay, we can get, so it will be 1 minus k times e to the power of negative 1 over 6 t to the power of 3 equals x to the power of 1 over 2. And finally, x just equals 1 minus k times e to the power of negative 1 over 6 t to the power of 3, okay, to the power of 2. Okay, so this is question 6. Okay, question 6. And now let's move to question 7. Okay, let's move to question 7. So question 7, use the substitution z equals y to the power of negative 1 to transform the differential equation into a differential equation in terms of z and x. Okay, so now, and solve it. Okay, solve it. So let's see. So we should replace, okay, dy by dx, so we should make y be the subject. So because z equals y to the power of negative 1, so y equals z to the power of negative 1. So dy by dx equals dz to the power of negative 1 by dx equals negative z to the power of negative 2 times dz by dx, okay, so, and then, so we can do a replacement, so we can get negative z to the power of negative 2 dz by dx minus, okay, minus 1 over x, okay, minus 1 over x, and y is 1 over z, y is 1 over z, and equals x plus 1 to the power of 3 over x, and y squared should be 1 over z squared. Okay, 1 over z squared. And now let's simplify it. Okay, so it is better to simplify the coefficient of dz by dx to be 1. Okay, so let's try. Okay, let's try. So we multiply z squared on both sides first. Okay, so it becomes negative dy by dx minus 1 over x times z equals, multiply z squared. Okay, so it becomes x plus 1 to the power of 3 over x. Okay, so here becomes 1, and again we multiply negative 1 on both sides, so it becomes dz by dx plus 1 over x times z equals x plus 1 to the power of 3 over x. Okay, over x, and check whether we can use integration by we can use separating variables method to do, or maybe one side can be written as the derivative of a product, or maybe whether it can be type 3. Okay, so actually if we multiply x on both sides. We multiply x on both sides. Okay, multiply x on both sides. Okay, if we multiply x on both sides, it becomes x dz by dx times z, plus z equals x plus 1 to the power of 3. Okay, x plus 1 to the power of 3. So you see now the left hand side can be written as the derivative of a product. Okay, so the two function is x and z, okay, and equals x plus 1. But if you don't know, okay, if you don't know how to or if you cannot find that we should multiply x on both sides, actually for this one you can multiply integrating factor. Okay, so you may also find integrating factor to do. Okay, but here it is really a tricky way. Okay, so we find that if we multiply x and then it becomes type 2. Okay, so now we multiply dx on both sides, and then do integration. And you see that this is x times y only, and equals 1 over 4 x plus 1 to the power of 4, and then plus constant c. Okay, plus constant c. So finally z just equals 1 over 4, and then x plus 1 to the power of 4 over 4 plus c over x. Okay, c over x. So finally, we can replace that by 1 over y. So it is 1 over y equals 1 over 4 and times x plus 1 to the power of 4 over x plus c over x. Okay, and take the reciprocal. Okay, take the reciprocal. So actually here we can combine it as one fraction. So it will be 4x, and here is x plus 1 to the power of 4 and plus 4c. Okay, 4c. 4c. Sorry, so here I make a mistake. Okay, so actually here this step it should be negative. Sorry, it should be negative. Okay, negative. I forget a negative sign. Okay, if we multiply negative, okay, you see we multiply negative 1. Okay, so it is negative. So here we should have negative sign, negative sign, negative sign, negative sign, and here is negative. Okay, negative also. So negative also. So finally here it should be, okay, it should be negative x plus 1 to the power of 4, and then plus 4c. Okay, plus 4c, and finally the value of y will be 4x over 4c minus x plus 1 to the power of 4. Okay, so this is question 7. Okay, so please be aware that just now I make a mistake here. Okay, I make a mistake. I forget the negative sign. Okay, please pay attention. Alright, so this is the exercise for